Hello everyone. In today's class, we are going to study about the cell's EMF and the internal resistance. Okay, this is the diagrammatic representation of the electrolyte cell. Okay, electrolyte cell, it is a device which is used to maintain steady current in an electric circuit. Okay, so it consists of two electrodes here. One is the positive, another one is the negative. These are dipped in the electrolytic solution. These electrodes, that is the p electrode and the n electrode, they exchange charges with the electrolytic solution. This positive electrode has the potential difference of V plus, and the negative electrode has the potential difference V minus. Positive electrode has the potential difference of V plus, negative electrode has V minus. So when there is no current in the, so here when there is no current, the potential difference between P and N, it is equal to V plus minus of V minus. It becomes V plus plus V minus. Okay, this is the difference. This difference, that is V plus plus V minus, this difference is called as electromotive force. Electromotive force of the cell. EMF of the cell, it is denoted by the small letter E. That is equal to V plus plus V minus. Okay, this value is always greater than or equal to 0. Right? This is electrolytic cell. It is a device used to measure the steady current in an electric circuit. It consists of two electrodes. One is the positive, another one is negative, and they are dipped in the electrolytic solution. Positive electrodes, these are having the potential difference V plus between itself and the electrolytic solution. Now the negative electrode is having the potential difference of V minus between itself and the electrolytic solution. When there is no current, then the potential difference will be equal to V plus plus V minus, or it is nothing but the electromotive force. It is denoted by small letter E. E is equal to V plus plus V minus, which has the value always greater than or equal to 0. Okay. Next we are going to study the significance of EMF, that is the electromotive force. For this we are going to consider the diagrammatic representation here, consisting of resistance R, a battery and a plug key here. So this is positive and this is negative. This is the resistance R. I will be the current flowing through this circuit. Okay. Let us consider a cell of EMF E. EMF is denoted by small letter. Let E be the EMF, comma, R be the internal resistance. R be the internal resistance. Then current through the circuit be I. I is nothing but the current through the circuit. Okay. Now the potential difference across R, it is taken as the sum of the potential difference across the terminals of the cell in the open circuit. V is equal to epsilon minus IR, because the potential difference across the resistance R is taken as the sum of the potential difference across the terminals in the open circuit, and V is equal to epsilon minus IR. We are considering here negative sign because the current flows from negative terminal to positive terminal. Okay, that is why we are considering the negative sign here. Okay, we have already studied the Ohm's law in the previous classes. It is given by Ohm's law. According to Ohm's law, we know that V is equal to IR. Value of V is equal to IR, you have to substitute here in this equation. It becomes IR is equal to epsilon minus epsilon alla idu small letter e, that is electromotive force. I am pronouncing it as a wrong epsilon. Okay, take it as electromotive force, small letter e. Now it becomes I is equal to E divided by R plus R, right? When R is equal to 0, when the value of R becomes 0, then the maximum current, that is I maximum, the maximum current is equal to E divided by R. Okay, so this is about the significance of electromotive force. What is internal resistance? We have mentioned here internal resistance. R is the internal resistance. It is nothing but the resistance offered by the cell to current flow. That is called as internal resistance. And this internal resistance, it depends on the distance between the plates, or it also depends on the nature of the electrolytes. It depends on the concentration of the electrolyte and nature of the electrodes, and also the area of the plates. These are the factors on which internal resistance depends. Okay.